Welcome to today's tutorial. So in this tutorial we're going to be discussing how to find derivatives of exponential functions. So this is not something that that is difficult to do. It's a straightforward thing. So we'll not even take time to solve these questions. Just do them just maybe less than 10 or 20 minutes. They are simple and straightforward. Okay, so if you have not yet subscribed to the channel, make sure that you do so that you don't miss out the videos that I'm going to be posting. And if you have any questions, contributions, or corrections in case I make a mistake as I'm solving, you can send them over to these lines. Okay. Alright, so the first question is f of x is equal to e to the power 2x. So the first thing you have to understand is that if you've been given, let's say, y, if you've been given y is equal to e to the power 2x. Okay, let me not start with this one. Let me just give an example in terms of symbols. Okay, if you've been given, let's say, y is equal to e to the power ax. So if this is what you've been given, we can use chain rule to solve this. So we're going to say let u be equal to ax, which is the power there. Meaning if we find du dx is just going to be a, and then the other thing is that the value of y now, the function y, will now remain as the e to the power, since we said u is equal to ax, meaning while there's ax we can replace with u. So dy du will now become e to the power u. So when you differentiate e to the power x, the answer is the same, e to the power x. So if you differentiate e to the power u, the answer will still be e to the power u, which is just the same as e to the power ax, because we know that u is just equal to ax. So to use chain rule, we know that dy dx according to chain rule is given by du dx times dy du. So du dx is simply just this expression here, which is a. So we have a times then dy du is simply just e to the power ax, e to the power ax, meaning the expression will therefore be a times e to the power ax. So dy dx is just the same as a to the power ax. What this means is that if you've been given any function that is in this format, what you just need to do is to differentiate the power and then multiply it by the original function. So if you differentiate the power, you're getting a, you multiply it with the original function, you get this. So a times the original function here, you get the value of dy dx. So I wanted you to understand what you are going to be doing. So in case they want you to show all the steps, you have to follow these steps which I've shown you here. That is if you want to use chain rule. So let us apply the same principle to this expression. So we have f of x is equal to e to the power 2x. So to find f prime of x will simply just be, we differentiate the power here. When you differentiate 2x, the answer you get is 2, and then you multiply by the original function, which is e to the power 2x. So applies to this expression here. We have y is equal to e to the power negative 8x. So you do the same. We differentiate the power there. You're going to get y prime will simply just be equal to, so y prime is just the same as dy dx, and y prime is going to be equal to, we differentiate negative 8x, we get negative 8, and then e to the power negative 8x. That's the original function. So applies to this expression there. We do the same. So we have y is equal to e to the power the root of x, which can also be written as e to the power x to the power half. So when you differentiate this expression, when you differentiate x to the power half, you are going to get okay, let's follow chain rule so that we see what we're going to have. So we say our u is equal to x to the power half, meaning u prime u prime is going to be equal to we differentiate this, so we're going to have half, then we have x to the power negative half, because when you subtract half minus 1, the answer will be negative half. So this can also be written as 1 over 2 root x when you simplify it further. Okay, so after writing it in this format, we can now multiply. So this is the derivative of the power. We can now multiply it with the original function to find y prime. So y prime will simply just be equal to 1 over 2 root x times e to the power the root of x. Okay, so this is the expression. We do the same with all the other questions. Let's check this one. So we have y. So I'm doing it very fast because I want us to meet at least some challenging questions. And then if I think it's good for you to follow the right procedure, like what I did here. You equate the power to u, and then you differentiate u, then you come and multiply it with the original function. That's called chain rule, because chain rule is used to differentiate composite functions. Okay, so we do the same even on this function. So we differentiate the power there. So the function first of all is e to the power negative 2x squared. So to find y prime, we first have to differentiate the power there, which will give us negative 4x. Then we multiply by the original function, which is e to the power negative 2x squared. That is how you differentiate. So this one is simple. You do the same. You can also solve that and send the solution over so that I check it, if in case you are doubting your solution. Even this one, you do the same. You just differentiate the power, then multiply it by everything. So for the sake of understanding, let me do this one. I'm sure some people might get confused because of the 5, which is the coefficient there. So we have y is equal to 5e to the power x squared plus 5. So we differentiate the power. When you differentiate the power to find y prime, when you differentiate the power, you're getting 2x. Then 2x, that's the derivative of the power. You multiply it with everything there that you have, which is 5e x squared plus 5. So when you multiply that, y prime becomes 2 times 5 there. That will give us 10x e to the power x squared plus 5. So as simple as that. So let's now look at this one. So to differentiate this one, we are going to use product rule, because we have two functions that are multiplying themselves. So we have the exponential function, which is e to the power x. We also have the line function there. So we are going to use product rule to differentiate that kind of a function. So how do we use product rule? So in case you don't know how to use product rule, you have you can check the description. You can check in the description. I'm going to put the link where I've explained how to use product rule step by step, and also quotient rule step by step, and also other rules of differentiating of differentiation rather. Okay, so I'm going to put it in the description. In case you failed to find it, you can just inbox me or text me on WhatsApp or any of the social medias available. Just search for Harmtedy. You find me there. Then you can text me there, and then I'll send you the link to the video where I've explained everything. Where I've explained at least some of the things that some of the simplest steps that you follow to solve to differentiate using product rule, quotient rule, and other differentiation rules. Okay, so we have this expression here. So we have these two functions, the exponential and the line function, multiplying themselves. Hence we're going to use product rule. So we have y is equal to e to the power x, then line x. So product rule states that if you have a function which is y is equal to u times v, the derivative, which is y prime, is given by u v prime plus v u prime, u v prime plus v u prime. Okay, so this is what you do. So our u is going to be equal to e to the power x, meaning our u prime is just going to be equal to e to the power x. When you differentiate e to the power x, the answer will still be e to the power x. Then our v is going to be ln x. Then to differentiate ln x to find v prime, you differentiate the function that you have there, which is just going to give you 1. When you differentiate x, you get 1. Divide by the original function x. So this is what you are going to have. So we now plug in everything into this expression. So when you plug in everything in the expression, you're going to have the value of your y prime in this case is just going to be, so the value of u is e to the power x. We're multiplying this by v prime. So v prime is simply just 1 over x. And then we say plus the value of v is ln x. We're multiplying this with v prime. So v prime is simply just, rather, we're multiplying it with u prime, which is simply just e to the power x. So our y prime becomes e to the power x over x plus e to the power x ln x. This is our y prime. Okay, so that's how you do such. Let's also look at this one. We're also using product rule here because we have two functions. We have two functions that are multiplying themselves there. So we have the function, the main function, which is y is equal to x e to the power 4x. So to find y prime, we need to identify your u and your v. So my u is going to be x, and my v is going to be e to the power 4x. So differentiating u to find u prime will give me 1. When you differentiate x, you get 1. Then differentiating v to get v prime, you get 4, because when you differentiate the power there, you're getting 4, and then you multiply by everything, which is the whole function. So we plug them in the product rule equation there. So we're going to have y prime being equal to u v prime. My u is x, and then v prime is 4e to the power 4x. Then we say plus my v is e to the power 4x, then multiplied by u prime. So u prime is simply just 1. So y prime is equal to, when you multiply everything there, we get 4x e to the power 4x. Then we have plus e to the power 4x there. So this is exactly what you get as your y prime after differentiating this. So this one is also straightforward. You use product rule. Even this one, you're going to use product rule, but because there's a negative there, let me help you. But it's still the same, because when you differentiate negative x, you just get negative 1. So there's no need of me solving that. So let's look at this one. We look at this one. I think we'll also look at some other bit complicated questions. So look at that. Yeah. So these are straightforward questions. Like I said, we will not spend a lot of time solving these questions. It's just a matter of knowing how to differentiate exponential functions. When you have e in the equation, how do you differentiate? That's all. Okay. So let me pick that one, which is g of t is equal to e to the power negative t plus e to the power t, then in brackets everything to the power 3. So how do you differentiate such a function? So you can use chains rule, because we have more than one function in this function, in this g of t function. So the first function that we have is u is equal to e to the power negative t plus e to the power t. Then the other function that we have is g of t is equal to u. While there's this part, I'm going to replace with u and then say to the power 3. So from this we can get u prime, which is, let me not say u prime but du dt from this expression. So du dt will simply just give me, when you differentiate the power there, I'm going to get negative 1. So negative 1 times the whole function there, I'm going to get negative e to the power negative t. Then we have this other function. When you differentiate e to the power t, you still have e to the power t. Why? Because when you differentiate t, you get positive 1. Positive 1 times the whole function, you still get e to the power t. So we also find the derivative of this function. So the derivative of this function, which I'm going to say, okay, let me not call this function as g of t, but let me give it another letter. Let me say, okay, let me say, okay, let me just say, okay, let it be g of t. There's no problem. So meaning we're going to find d g of t du, which is just going to give us 3 u squared. You differentiate that using the power rule. Okay. So we now plug this into the chains rule. Yeah. So this one is okay. In this case, we're using g of t. So meaning we're not going to use dy dx. Let's say g of t prime. So we say g of t, g prime of t is simply just going to be equal to the du dt times the g of t du. So this will give us du dt is simply just what we found there, which is just e to the power t minus e to the power negative t. Then we're multiplying this with the g of t, which is this expression there, which can further be written as in terms of, because we know that u is this function there. So we say 3, while there's u, we're replacing with e to the power negative t plus e to the power t. Then we say squared, that's squared. So we're multiplying it with that. So e to the power negative t plus e to the power t squared. So our g prime of t will therefore be equal to 3 e to the power t minus e to the power negative t in brackets, then times e to the power negative t plus e to the power t squared. So this is what you get as your solution. Okay, so these things are very simple and straightforward. Okay, let's look at this one. Yeah, so I think I'm going to end on this one. I'll see if I'll get another question from here. Then we'll see what we're going to do, because the rest of the questions are simple. The only thing that you need to, okay, I'll just show you how to solve them. I may not solve them, but I'll show you how to solve them. Okay, so for this one, which I'm about to start solving, remember the rules of differentiating a line function. So we have y is equal to ln 1 plus e to the power x, e to the power 2x. So the rules of differentiating a line function, you differentiate the function which you have there, then divide by the original function. So when you differentiate this function, so to find y prime, you get the derivative of this function will give you 2. When you differentiate the power, when you differentiate 1, you get a 0, but when you differentiate 2x there, you get 2. then times the original function, which is e to the power 2x, then everything divided by the original function, since it's a line function, which is 1 plus e to the power 2x. So this is the solution. So that's why I'm saying the remaining questions are very simple. Even this one is a line function, so meaning you start first by differentiating what is in the brackets, then divide by the original function, which is everything there. So differentiating what is in the brackets there, as you can see, there are two functions in the brackets which are dividing themselves. Hence you can't just differentiate that directly, but you need to employ a formula that is the quotient rule, which deals with a function that is in the format u over v. That is why you apply the quotient rule, which says dy dx will then be given by v u prime minus, rather, this one is minus u v prime everything over v squared. That is the quotient rule. And then you also have this function here. So even this function, you can use the quotient rule if you want. And then as you are using the quotient rule, put in mind that you have e in the function, meaning you have to differentiate e as well. I mean, you have to be differentiating e according to the rules that I'm just from teaching you. Even this one is almost the same, similar to this. You can do the same. But for this one, if you want, you can first split it to y is equal to e to the power x over 2 minus e to the power negative x over 2, and then you differentiate this. So the derivative of this is simple. This one is not very long, that's why I'm solving it. So the derivative of the first part, you get the same thing, because when you differentiate e to the power x, you get e to the power x. Then the derivative of this, you differentiate the power, that will give you negative 1. So we have negative 1 there. Then we're multiplying everything with the original function, which is e to the power negative x over 2. So meaning the derivative of that will simply just be e to the power x over 2, then plus e to the power negative x over 2. That's the derivative of that. This one, you just have to use quotient rule. This one, you also use quotient rule. Then this one, you have a product rule there. You have two functions. You have this one, and then you also have this function there. So we have this trigonometric function. You have to understand that the derivative of sine x is cos x. The derivative of cos x is negative sine x. Yes, so once you just know those two derivatives, you can solve this expression. So the derivative of sine x is cos x. The derivative of cos x is negative sine x. And you are done. That's how you solve. Then even here, you can do the same. Differentiating tan 2x is also straightforward, but because you are multiplying e to the power 2x and tan 2x, you have to use the product rule. You get your u as e to the power 2x, and then your v is going to be tan 2x. Here you get your u as e to the power x, and then your v as sine x plus cos x, and then you differentiate them using the product rule. Okay, so thank you very much for watching today's tutorial. If you have not yet subscribed to the channel, make sure that you do so, and please ensure that you also click the notification button so that you don't miss out the videos that I'm going to be posting. My name is Harmtedy. In case you want to be added to the WhatsApp group where I post all these tutorial videos, make sure that you contact me on any of these lines on the screen. My name is Harmtedy. See you in the next tutorial video. Shalom, shalom.